Let's start with NL2 connectors on 2-conductor 14 AWG wire. You slice open the outer jacket. You need to be careful because you might slice open the conductors a little bit, so you can't go too far in. Remove the outer jacket. It will expose 2 conductors and fabric. Cut the fabric down all the way to the jacket. And it will leave you with a positive and negative. Strip the wires. Again, this is 14 AWG. Twist the copper ends. That will help with fraying and keep the strands together. It's a bit long and there's a bit of a fray at the end, so I trim the conductors. All the little copper is gonna make a big old mess on your table. Remember to put the boot on before you start screwing into your terminals. Also put on the strain relief. I forget this pretty frequently, but luckily it is not too late. This is an NL4 connector. Black goes into 1+, white 1-. This accepts 4 conductors, but we only have 2. We only need 2 in this case. Screw the wires into place. Do not over-tighten. It is possible to over-tighten and damage the internals, and then you wouldn't be able to reuse this connector later. Bring up the strain relief. It is keyed, so you need to find out where it lines up exactly. It will kind of lock into place once you find it. Grab your shell, slide it on correctly, which I do not do here. I drop it, and then I slide it on more correctly now. And screw in the boot to the shell. Give it a big twist. And there you have it. This is a RJ45 Passthrough. There is the standard version and the pass-through version. We are going to be doing the pass-through version. I have a crimper in the background that is new, and it comes with some pass-through connectors. They are easier to start. So I've removed the outer jacket, and I am separating and untwisting the pairs. I'm going to speed this up a little bit because it takes a little while and it's a little fiddly. There are 2 different kinds of standard pinouts. This one is more common. This is the T568B pinout. You don't need to memorize all those letters. Just remember that B is the good one. The A pinout has its uses in different applications, but in the theater, you will more commonly see the B version of the pinout. Also remember to slide on the boot, if you forgot, which I seem to have. Going to have to make sure my wires are correctly aligned one more time, and then when they are, slide them in. With the pass-through connector, you can go all the way up, and all the wires will go through the little holes at the top of the connector. Shove as far as you can going up, because the compression is going to have to happen on the outer jacket right there. I'm going to trim the excess wire so that it doesn't get caught in my blade when I try to send this through my crimper. Insert it into the slot labeled 8P for 8 pins. And give it a big squeeze. All the way down. So the blade on the back of the crimper theoretically should have cut all of the wires flush to the top of the connector, but you might need to pop a couple off if it didn't take. Slide the boot over, and there you have it. That is an Ethernet from the front and from the back. We have balanced audio cable, which is 2 conductors and a shield. Especially with shielded cable, you will want to be careful about the depth that you cut, because it is easier to cut directly into the shield and ruin a couple strands. Luckily, I am successful here, and I can begin to separate out the shield. I want to gather it to one side so that I can kind of bunch it together. Start giving it a twist from the jacket outward. And trim your fabric, otherwise you will be burning it with a soldering iron. Grabbing your wire strippers, strip the conductors about halfway. This is 24 AWG. And give those strands a twist together as well. I have my solder and my soldering iron. We are going to do what's called tinning the wires, which means coating through the copper with solder. I am pointing the conductors more downwards to let gravity help me coat with solder. I have a wet sponge as a part of my soldering iron kit, which I will wipe my iron on periodically. Trim the ends. They do not need to be that long. I am deliberately cutting the shield shorter than the other wires because it is thicker and will better hold up to strain than the thinner wires. You also need to put solder in the terminal cups. There is actually already solder in there because I am using an old connector. The solder from my tinned wires and the solder from my cups should fuse together when applying the iron. Now that my ground is soldered into pin 1, I can start setting up the next wire for pin 2. I'm holding my wire with a pair of needle nose pliers. You do not want to do this with just your fingers because you will get burned. But I also don't want to hold it with the needle nose pliers too long because then it will also transfer heat and melt the jacket. I like to save pin 3 for last because it is on top and I have less likelihood to run into the other wires with the soldering iron. I'm doing this one without my needle nose pliers this time because holding the outer jacket a certain way seems to be holding it in place just fine. Do not grab your connector directly, it is very hot. Do not handle it by the metal pins right away. They still need to cool down. Once they are cool enough, you can fit the strain relief. Not pictured here very well. A little off screen. And when that's in place, you can slide the shell on top. It might take some doing. And once everything is in place, you can screw the boot on, which I hope you remembered to put on. On the other side of that cable, I have a Switchcraft female. The previous connector was an XLR Neutrik male. Using needle nose pliers, you will have to bend out the tabs in order to fit the outer jacket. Next up, tin the terminals. These terminals seem to be free of old solder, though this is an old connector. Once the terminals are tinned, you can solder ground to pin 1, which will occupy the right side since this is a female connector. On the previous Neutrik connector, it was on the left because it was male. Same thing for pin 2, it's going to be soldered onto the left because this is a female version of XLR. And pin 3 will remain being the top facing pin. Now that you are soldered and the outer jacket is in place, you can compress the strain relief tabs. So this is to keep the outer jacket steady. All right, grab your shell and then realize that you should have put it on earlier. And you didn't. And it doesn't fit. So now you have to unsolder everything. This happens sometimes. But then you can put the shell on, like you were supposed to do earlier. And then you can solder ground to pin 1, and solder positive to pin 2, and pin 3 is on top. That would be negative. Compress the strain relief tabs, again, but this time with feeling. And now you can slide the shell up, because it was already there, like it was supposed to be. Cram the bottom strain relief inside. I don't know what else to do other than cram it. And then tighten the little set screw. And flip it the bird, apparently. One more connector. This is a 1/4" TRS male. Tip ring sleeve. Right now I am applying solder to the sleeve, which is going to be for our ground wire. This one also has those same kind of compression tabs, so you have to undo them so you can redo them. I'm going to solder the ground to the sleeve, which is the big terminal. Sometimes I find it easier to rotate the whole connector while working with either ring or tip. This one would represent ring, it is the medium one, and tip is the tiny baby one. I am going to fiddle with the wire because 24 AWG is actually small enough to fit through that hole. So I am getting it through the hole and kind of bending it out and compressing it. Then I'm going to put some solder on top once it's set. I noticed this after the fact that I probably wanted to put red there instead of white if I was following the previous convention with XLR. There's actually nothing on the other end of this cable, so all I would need to do is match this color convention that I've done on this side, as long as they match on both sides. But if I was connecting this to the XLRs that I previously just soldered, you saw it on tape about a minute ago, the pins would be reversed, and it would not work. But luckily, this was just a demonstration, and I'm allowed to do it wrong because it's not going on a show. always check your cables. And always make sure that you are going to the proper pins on both sides. Going to melt some solder onto the tip conductor. That will be our final one. And we're soldered. Once again, compress the tabs onto the outer jacket with pliers. I believe I did put the boot on this time, but it fell right off the other end. But luckily there is no connector on the other end blocking it from being put on the opposite way. Screw on the boot. And let's go.